In this episode, we move into a way of thinking that helps beginners understand why resilient organizations do not assume that the main system, the main person, or the main process will always be available when needed. Redundancy sounds simple on the surface, but it becomes much more valuable when you connect it to business continuity, BC, and disaster recovery, DR, instead of treating it like a spare part sitting off to the side. A security-minded organization has to assume that outages, mistakes, equipment failures, natural events, supplier problems, and human absences will eventually happen somewhere along the line. When that happens, the goal is not only to survive the moment. The goal is to keep essential work moving, protect what matters most, and recover in a way that is organized rather than chaotic. Redundancy thinking supports that goal because it trains you to ask a very practical question before trouble arrives, which is what happens if the main thing we depend on suddenly stops working. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A beginner often hears redundancy and imagines waste, duplication, or unnecessary cost, but that is too narrow and often leads to poor security and operations decisions. Redundancy is really about reducing dependence on a single point of success by making sure there is another path, another copy, another person, another location, or another method available when the first one fails. That does not mean creating endless duplicates of everything without discipline. It means being thoughtful about where failure would hurt the organization most, and then building enough backup capability to prevent one broken link from causing a larger collapse. A good redundancy mindset is therefore not about excess for its own sake. It is about preserving the ability to continue serving the mission when something expected becomes unavailable. That idea matters because many organizational failures do not begin with a sophisticated attack. They begin with a very ordinary disruption that turned into a larger crisis simply because there was no backup plan, no alternate path, and no second option ready when the first one disappeared. One of the fastest ways to understand the value of redundancy is to think about single points of failure. A single point of failure exists when one person, one system, one connection, one supplier, one site, or one fragile process carries so much dependency that its loss stops everything important behind it. That is dangerous because the organization may feel stable during normal conditions while actually depending on a surprisingly narrow base of support. A single server, a single cloud region, a single spreadsheet owner, or a single employee who knows how a critical process works can all become serious weaknesses if nothing else is ready to take over. Beginners sometimes focus only on malicious threats, but redundancy teaches a broader lesson. A power failure, illness, hardware problem, accidental deletion, transportation issue, or simple human absence can be just as disruptive as deliberate attack if the organization built its daily work around the assumption that the one important thing would always be there. Redundancy begins by learning to notice those fragile points before they fail in real life. This is where B, C, and D are become easier to understand when heard together but kept distinct. BC is about keeping important business functions operating through disruption, even if the organization has to use alternate methods, reduced capability, or temporary workarounds for a period of time. DER is more specifically about restoring systems, data, infrastructure, and technical capability after a disruptive event so normal operations can return in a more complete way. BC therefore asks how the business continues to function, while DR asks how the technology and supporting environment are recovered. These two ideas support each other, but they are not identical. A company may continue a critical customer process manually for a time under B, C, even while its technical teams work on D, or to restore the supporting platform. Redundancy thinking belongs to both because continuity depends on having alternate ways to keep work moving, and recovery depends on having alternate copies, alternate capacity, or alternate environments that make restoration possible when the original setup is damaged or unavailable. A very important beginner lesson is that redundancy is not just a technology topic. People can be single points of failure too, and many organizations quietly discover this only when someone is sick, leaves the company, or becomes unreachable during a stressful event. If one person alone knows the recovery steps for a critical system, understands a sensitive reporting process, or can approve an essential operational action, then that knowledge concentration becomes a real continuity problem. Good redundancy thinking, therefore, includes cross-training, shared documentation, backup approvers, and enough role clarity that critical work does not depend entirely on one individual remembering everything under pressure. This is not about insulting expertise or pretending everyone can replace everyone else instantly. It is about making sure the organization is not helpless if the primary person is unavailable at the worst possible moment. Beginners should notice how practical this is. Security and continuity become stronger when important knowledge is shared carefully. Critical responsibilities have backup coverage, and no essential activity is trapped inside one person's memory or personal habits. Processes also need redundancy, because even when staff are present and systems exist, a rigid process can fail if it assumes the usual route will always be available. A continuity-minded organization asks whether an important task can still be performed if the normal software is down, the normal office is closed, the normal approver is absent, or the normal communication channel is interrupted. Sometimes the answer may be a temporary manual process, a simplified workflow, a different communication method, or a reduced service model that keeps the mission alive until fuller recovery is possible. Beginners often think resilience means having a perfect backup version of the same process, but that is not always realistic or necessary. Sometimes resilience means having a workable substitute that protects the most important function even if it is slower or less convenient. That insight matters because continuity is not always about elegance. It is about preserving essential outcomes under imperfect conditions. Redundancy in process design helps the organization keep moving when the preferred method is suddenly unavailable. Technology redundancy is often the first thing people picture, and it does matter a great deal. If one system hosts a critical service, the organization may need alternate capacity, alternate infrastructure, alternate networking paths, or alternate storage arrangements so that one technical failure does not take the entire service offline. This does not require every beginner to become an engineer, but it does require understanding the principle behind the investment. A well-designed environment avoids placing all essential capability into one fragile location or one unprotected dependency chain. It also recognizes that recovery is much harder when there is no spare path, no protected copy, and no tested way to shift operations after disruption. At the same time, technology redundancy should be tied to real business need. Not every system deserves the same level of duplication, and not every interruption causes equal harm. The stronger decision is the one that aligns redundancy with the importance of the service, the cost of downtime, and the consequences if the organization cannot restore capability within a reasonable period. Backups are one of the clearest examples of redundancy, but beginners should understand that a backup is only useful when it supports actual recovery rather than offering false comfort. A copied file that cannot be restored, a backup that was never tested, or a backup stored carelessly in the same danger zone as the original does not provide the resilience people think it does. This is why organizations often think in terms of recovery time objective, RTO, and recovery point objective, RPO. RTO helps express how quickly a function or system needs to be restored after disruption, while RPO helps express how much recent data loss the organization can tolerate if recovery becomes necessary. Those ideas matter because not every business function has the same urgency, and not every dataset can absorb the same level of loss. Redundancy becomes more meaningful when it is designed with those realities in mind. A protected copy is important, but a protected copy that can be restored within an acceptable time and data loss window is what truly supports BC and DR in practice. Physical and environmental redundancy also deserve attention because digital resilience still depends on real-world conditions. A second power source, backup connectivity, alternate workspace, protected equipment location, or dependable environmental controls can make the difference between a manageable incident and a major operational breakdown. Beginners sometimes forget this because cybersecurity often sounds like it lives entirely inside networks and software. Yet physical disruption can quickly turn into information disruption if devices, offices or support systems become unusable. A continuity-minded organization does not ignore that connection. It asks whether essential work could continue if a building is inaccessible, if weather affects transportation, if a local outage affects communications, or if equipment in one place becomes unavailable. Redundancy here may involve alternate sites, remote work capability, extra communications methods, or protected facilities arrangements depending on the mission. The larger lesson is that continuity is shaped by the full operating environment, not just by the condition of the primary application on a normal day. A strong redundancy mindset also requires prioritization, because not everything can or should be duplicated to the same degree. Beginners sometimes hear resilience language and assume the right answer is to create a backup for every possible thing. But that can become expensive, confusing, and hard to manage without improving the most important outcomes. Better thinking begins by asking which services, systems, processes, data, and roles are most critical to the mission and what level of interruption would be acceptable for each one. Some activities may tolerate delay. Others may need rapid recovery or alternate processing almost immediately. This is where B, C, and D are planning become practical rather than theoretical. The organization identifies what truly must keep going, what can be restored later, and where redundancy will provide the highest value. For beginners, this is a useful reminder that security judgment is often about proportion. Strong continuity planning does not treat everything equally. It protects what matters most with the most deliberate attention. Testing is what separates hopeful redundancy from dependable redundancy. An organization may claim to have backup communications, alternate procedures, recovery copies, or substitute facilities. But until those alternatives are exercised under controlled conditions, no one knows how well they will perform when stress is real. Testing reveals missing steps, unclear ownership, outdated documentation, hidden dependencies, and assumptions that seemed reasonable on paper but fail under pressure. This matters because disruption rarely arrives politely. When a real incident occurs, people are already under time pressure, and that is a terrible moment to discover that the backup process requires unavailable credentials, the alternate location lacks key equipment, or the recovery steps were written for an older version of the system. Beginners should hear this clearly because it changes how you think about preparedness. Readiness is not proven by possessing a plan. It is proven by practicing enough that the organization knows where the plan is strong, where it is weak, and what must be improved before the next serious event arrives. There are also several misconceptions that can quietly weaken redundancy planning. One is the belief that cloud use automatically solves continuity and recovery without the organization needing to understand its own dependencies, recovery expectations, and business priorities. Another is the assumption that having a backup means having resilience, even when restore time, data freshness, or access to the backup were never truly examined. A third is the idea that redundancy only matters for catastrophic disaster, when in reality many continuity failures come from much smaller disruptions, such as employee absence, vendor delay, local outage, human error, or a single broken device supporting an essential task. Beginners benefit from hearing this because it makes the topic feel more real and less dramatic. Redundancy is not only about surviving the worst day imaginable. It is about preventing ordinary disruption from becoming extraordinary damage simply because the organization depended too heavily on one path and never built a second one. Scenario-based questions and real workplace decisions often become easier when you carry this redundancy mindset into them. If a question describes one administrator who alone can restore a critical service, one communication method for emergency coordination, one storage location for vital data, or one supplier supporting an essential operation, the real issue may be fragility rather than a flashy technical failure. The strongest answer may therefore involve alternate capability, cross-training, protected backups, additional communication paths, or another measure that reduces dependence on a single fragile point. Beginners sometimes miss that because they are looking for the most technical-sounding solution rather than the most resilient one. Redundancy thinking helps correct that habit. It trains you to ask what fails if the main thing disappears and whether the organization has another workable option ready. That single question is often enough to reveal why a system, process, or role is riskier than it first appeared. As you grow more comfortable with this subject, You begin to see that redundancy is really a habit of mind as much as a set of spare resources. It encourages you to look at important work and ask where it is fragile, where too much trust has been placed in one component, and where a second path would dramatically reduce organizational pain during disruption. That makes it valuable far beyond formal continuity and recovery planning. It improves how you think about staffing, communications, data protection, vendor dependence, infrastructure, and operational design more broadly. A resilient organization is not one that never experiences failure. It is one that expects failure somewhere, prepares for it honestly, and builds enough alternate capacity that important functions do not collapse the first time the preferred path disappears. For beginners, that is the deeper lesson worth carrying forward because it turns continuity from a distant emergency planning topic into a daily way of noticing and reducing hidden operational weakness. As we close, remember that building redundancy thinking around BC and DR is not about fear, waste, or duplicating everything without purpose. It is about recognizing that important work should not depend entirely on one person, one process, one system, one location, or one fragile chain of support. BC focuses on how the organization continues its essential functions during disruption, while DR focuses on how technical capability and supporting systems are restored after harm occurs. Redundancy strengthens both by making sure there is another path when the main path fails. That may mean shared knowledge, alternate procedures, protected backups, extra infrastructure, secondary communications, or other carefully chosen backup arrangements. Once you start thinking this way, continuity and recovery stop feeling like specialized emergency topics and start feeling like practical security judgment. You begin asking not only whether something works today, but whether the organization could still function tomorrow if the primary option suddenly vanished. And that is one of the most useful resilience questions a beginner can learn to ask.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.